Okay, today we will learn about numerical methods, root findings. First thing you need to know is what is numerical methods. So numerical methods is a method that you use and you get an approximation value for your answer. Not a true value. An approximation is a value that is very close to the answer. Okay. And under numerical methods, we have root findings. What is root findings? Okay, before this, you have a function. Let's say your function is x squared minus 4. Then you have to find your x. So your function is equal to 0. X squared minus 4 equals to 0. So you can find your x, right? Okay, you can factorize. So your x will be negative 2 and x equals to 2. So this is what we call root finding. You are finding the x. Okay. Why we call it root findings? When you substitute back the x into the function, your answer will be 0. Okay, that is actually root findings. But for numerical methods, sometimes our equation is not like this. Sometimes we have a very complicated equation like e power of negative x. We have log x. Maybe you have a log 2x plus e power of x plus sine everything. Let's say you have an equation like that. So that's why we need numerical methods. Because numerical methods will represent this complicated function into a method that you will use and you will get an approximation value. It will represent this complicated function in a simple method. Okay, computers cannot do general mathematical problems. They can only repetitively apply arithmetic primitives to input. Okay, so this one is it's okay. I'll skip this. Okay, problem dependent decision. Okay, approximation. Since we cannot have exactness, numerical methods, our answer will always in approximation. So we have to specify our tolerance to error. Plus, you have a convergence. We also specify how long we are willing to wait for a solution. Okay, because numerical methods, it depends on the iteration. You will do several iterations. Means using this formula, you will have to repeatedly do until you get the final answer. This is what we call convergence. Method, which is a method easy to implement and yet powerful enough and put a human in the loop, since no general procedures can find roots of complex equation. We let a human specify neighborhood of a solution. Okay, so I will straight away go to the root findings method. In our syllabus, we will cover bisection method under bracketing methods. Next, fixed point iteration, Newton-Raphson, and secant. So we have 4 methods for you to study. Okay, we will start with bisection method. Bisection method basically, there will be a graph. Okay, this graph is your function, right? Okay, so maybe you will get a very complicated graph, but this one they just want to show you a simple graph so that you can know what bisection method do. Okay, so actually you are finding this root, right? The one that you will get your answer equals to 0. So this is actually you are looking for. But in this case, they give you an interval from A to B, but you don't know where is your root. In this case, we can see the root is here, but what is the value here? Right? What is the value here? So bisection method do from this what bisection method do? From this interval A to B, they will cut into half. This one, bisection method will cut the interval into 2 halves and check which half interval contains the root. It will cut the interval in halves until interval result is extremely small. Okay, Just now we have A to B. You are looking for this root. So from A to B, they cut into half here, and then they check your root is here or here. So that's why they are using middle point equation. Okay, after that, they have checked that using this algorithm, they find that your root is from A to B. Just now we have A to B here is a bit bigger, but now it becomes small, right? Okay, they have an algorithm whether you so they will keep cut until you get the answer. Okay, so I will show you. This is the algorithm. What you need to know in bisection method is this one, FA times FB. Not that one. Okay, in this part you have to know an equation for middle point, and then if FA times FM is less than 0, your answer will be B equals to M. But if FA times FM is more than 0, it will be A equals to M. Okay, what is this? Nanti kita tengok. Actually, yang ini FA times FM ni, this one, this FA times FM, when it is less than 0 means it is means it is negative answer. So when it is negative, B equals to M. But when it is more than 0, it is positive answer. So your answer is A equals to M. Okay. Let's start with the examples for you to get a clear view. Example 1. Using the bisection method, find the root of fx equals to x power of 6 minus x minus 1 equals to 0. Okay, accurate to within E equals to 0.05. This one is your error. And then they give you xa equals to 1, xb equals to 2. Okay, this is the question. This is your answer. Your answer, you should start with a table. So you should draw a table. So this is your step number 1. Draw a table. First column, you should write n. N is just a number of how many iteration that you are doing. Okay, and then the next column is xa. The third column is xb. Fourth column is xm. And then you have a column with fxa, this one, fxm, and the last column is xb minus xm modulus. This one is actually error. Okay, so you start with the first row. This is your first row, n equals to 1. So what value you have to put here in xa? The one that they give you, xa equals to 1, so that's why they put 1. And then they give you xb equals to 2, so that's why they put 2 here. Okay, for xm, you have to use middle point equation. Middle point equation, remember, xa plus xb over 2. So in this case, 1 plus 2 over 2, you get 1.5. Okay. After that, the next column, you have to find fxa. To find fxa here, you substitute this value of your xa into equation here. So you will get answer here, -1. That is your answer. And then for your the next column, fxm, here, you substitute your value of xm here into this equation. You get this answer here, 8.8906. Okay, that's how you get the answer. And then the last column, find the error, xb minus xm. So in this case, your xb is 2, xm is 1.5. Okay, 2 minus 1.5, that's why you get 0.5. Okay, now check. Your error is 0.5, but they want you to give an accurate until 0.05. So this one is still larger than the given error, so you need to do the second iteration. So you have to continue the same technique for the second one. So I will delete this for you to get a clear view. Okay, so we start with number 2 here. Okay, we continue with number 2. Now, where to get your XA and XB? Okay, remember here, you have to take note with this, the one that highlighted with green color. If FA times FM is negative, then your B equals to M. Okay, let's see here. So from your previous iteration, we are doing this one, number 2. But look at your previous. You have to check FA times XM here. So this one is negative, this one is positive. Negative times positive, the answer will be negative. When your answer is negative here, B equals to M. Okay, so your B here will follow the M before, like that. So basically, you are copy the value of M into B. Okay, for XA, you keep the value. Okay, you get what I mean? And then after that, you have XA, XB, find your XM using middle point formula again. So 1 plus 1.5 divided by 2, you will get 1.25. And then for this one, for the next column, fxa, you substitute your value of xa here into the equation, you get this answer. For fxm, you substitute value of xm here into the equation, you get the answer here, 1.5647. Okay, and then for the error xb minus xm, error xb 1.5, xb 1.5 minus xm 1.25, you get 0.25. Still larger than the given error, so you need to continue with the next iteration, which is the third one here, the third number here. So what you need to do, check your fxa times fxm, right? So this one is negative, this one is positive. Negative, positive, the answer is negative. So your xm copy into B. Okay, and then the other one you keep it. Okay, after that, using to find xm using formula 1 plus 1.25, you get over 2, you get 1.1250. And then fxa, as usual, substitute a into this equation, you get this answer. fxm, as usual too, substitute xm value into this equation, you get this answer. And then for error xb minus xm, your xb is this one minus xm, you get this answer, modulus. Okay, the answer for error is still larger than the given error, so that's why we continue with the fourth iteration. So I'll delete this. Okay, we continue with the fourth. For number 4, still we have to check xb and xm before. So this one, the answer is negative, negative, so it should be positive. Negative times negative, positive. So your xm here, you copy into A. Because when your answer is positive, A is equal to M. Okay, now this is your XA. For the other one, XB, you keep the value. Okay, and then this one, XM using middle point equation, and then fxa, you substitute xa value into equation, you get fxa. You substitute xm value into this equation, you got fxm value. And then error, as usual. Okay, still larger, then you have to continue with the fifth iteration. So, for fifth iteration, check iteration before, the answer is negative. Here is negative, positive. So, you should copy xm into B. So, that's why this answer is equal here. And then the other one, you keep it. And then you continue until the error here. The error now is 0.0312, which is lesser than the given error here. So, you can stop. So, you stop here. But which one is your final answer? Your final answer is XM here. This is your final answer. Okay. So there is a pros and cons for bisection methods. The pros is guaranteed to converge. Converge means your answer is getting smaller. Like that. And then the error bound decreases by half with each iteration, but there is a cons. Converge very slowly, cannot detect multiple roots. Okay, next method we have fixed point iteration method. In this method, you will use this one, x equals to gx. Okay, let's straight away go to the algorithm. Given an equation fx equal to 0, convert the fx equal to 0 into this form, the one in the green box just now, x equal to gx. So this one is important. Okay, this one. Okay, let's start with the example. Use simple fixed point iteration to locate the root of fx equals to, okay, they give you this function and then they want you to find until accurate 0.0001. Okay, we can rewrite the equation. Okay, first step for fixed point iteration method, this is your first step. You have to find gx. In this case, gx is equals to x. Okay, using the equation they give you fx equals to, from the question, e power of x minus 3x squared equals to 0. So for first method, you have to find x. Let your x be the subject. So I will move 3x squared to the other side equals to e power of x. And then I want to find x only. So e power of x over 3. So my x will be e power of x over 3x. So that's why you get this one. So that one is the first step. Second step, assume x0 equals to 1. Sometimes they will give you the x0, but if they don't give you x0 value, usually you will use 1. Okay, so for the third step, you start with drawing a table. So your first column is I, second column is xi, third column is your error. Error here, xi minus the x previous. Okay, now start with iteration number 1. The first iteration. So you have to find the value here, right? You don't know what is the value here. This one. So what you need to do is, now you have to find x1 because this one is iteration 1. You have to find x1 here. Okay, what you need to do is, your x 0 is 1, right? Okay. You substitute the value of 1 into this equation. It will be e power of 1 over 3 times 1. You will get this answer. Okay. For the error, 0.9061 x1 minus x0. Using this formula, it will be x1 minus x0. So x0 is 1. So you will get your answer for error. Okay, since the error is still larger, this one they leave it blank. Since the error is still larger than the question, you have to continue with second iteration. So for second iteration, take this value, you substitute into here, you will get this answer. And then check your error, still larger. So for third iteration, take the previous value, substitute into here, you get this answer. Still larger, continue with the next one, take this value, substitute into here, you will get this answer. And check the error. Now your error is 0, lesser than the given error, so you can stop. So now which one is your x? Your x is the one in this box, the last column, the last row for your column xi. So this is your final answer. Okay, there is a pros and cons. The method is guaranteed to converge. The pros, error bound decreases by half, same like bisection just now, but the method converge very slowly and cannot detect multiple roots. Okay, the next method, our third method is Newton-Raphson. This Newton-Raphson, they derive it from Taylor series, and then this one is from your Taylor series, and then they have rearranged for you. So in Newton-Raphson method, we will use this formula, the one in the green box. Okay, this is the algorithm, the formula just now, the one in the green box. Okay, let's straight away go to example 3. Example 3, the question. Use the Newton-Raphson method to estimate the root of fx employing an initial guess of x0 equals to 1, accurate to within e equals to 0.001. Okay, so this is the question they give you. Now, for the first step, you have to find f prime x. F prime x is actually differentiation, dy dx. So from this given function, you find your f prime x. In this case, they have showed to you. So how they get that? How they get this is they differentiate. So second step, you do the table. Draw the table. So first column is your iteration number. Okay, for this case, they start with 0, and then you have xi, fxi, f prime x, fxi over f prime xi, and last column is your error. Okay, this one you have no choice, you need to know. Okay, Newton-Raphson, you have to find this one and this one because, and also this one because it is in the formula. That's why we are looking for fxi, f prime xi. Okay, now I will show you the 0 iteration here. Okay, they give you x0 is 1 here from the question. So that's why in this table, x0 is 1. After that, find your fxi here. The next column, find your fxi. How? You substitute this value into f equation because this one is f. So you get this answer. And then for the next column, you substitute the value of your xi, still 1 here, into f prime x because you are looking for f prime. So that's why you get the answer here. You substitute here, you get the answer here. You substitute here, you get the answer here. Okay, and then let me delete this. And then for the next column, you have to find this one, right? You have to find this one. So this one, you just divide this one with this one, you get this answer. Okay, same just like just now, they didn't find the error because they know the error is still bigger. We don't have the previous error. Okay, you have x0 but you don't have the previous before 0, like that. That's why they leave it blank. Okay, for the next iteration, this time or your I will be 1. So find your xi. How they get the xi? They are using this formula. Okay, let us see. From this formula, when you want to find your x1, the formula will be x0 minus f x0 over f prime x0. Same thing, if you want to find x2, it will be equals to x1 equals minus fx1 over f prime x1. Okay, for this case, how they are finding this value? X0 minus the division tadi. So it will be 1 minus this one. You will get this answer. Okay, and then continue with the second column. Substitute this value into f equation, you get this answer. And then the next column, substitute this value into f prime equation, you get this answer. And then for the next one, you just divide fx1 over f prime x1, you get this answer. And then find your error. Your error will be this one. It will be x1 minus x0. So x1 minus x0, which one? x1 minus x0, you get this answer. Okay, check the error is still larger than the given error here. This one, given error here. So you have to continue with the next iteration. Okay, same step. So we are at this one, the second number 2, iteration number 2. So to get this value, this one minus this one, right? So you get this value. And then for the next column, substitute this value into f, you get this answer. Substitute this value again into f prime, you get this answer. This one is just division, this one divide by this one, you get this answer. For the error here, x2 minus x1, you get this answer. And you have to continue until your error is lesser than the given error. So which one is your answer? Your answer is in the column xi, here in the last row. So that's why that is your final answer. Okay, still there is a pros and cons. The pros is the method is very fast, error decreases rapidly, but the cons is bad choices of x0 can get you using bad choices of x0, the method can fail to converge. Okay, x0 initial guess, because we have to take an initial guess here, right? So it is a convenient method, plus it is a convenient method if your f prime x can be evaluated analytically. Okay, if it is easier for you to differentiate, so you can use Newton-Raphson. Okay, the last method is the secant method. Secant method is a recursive method to find the solution to an equation like Newton method. Okay, so for secant method, they are using formula 2. So this is the formula for secant method. So from this formula just now, this is your question. They substitute this equation into your fx.